Okay, we're doing rotations. That's right, we're turning things. Now, a rotation, basically I think about it like this. There's a point, and that point's called the center of the rotation. And imagine you're just driving a nail or a thumbtack right through that center and then using it to pivot a pre-image. So we're rotating it around that center point. Now, when you do a rotation, there's a few things to keep in mind. First of all, the angle or the direction that we're going to do our rotations in, unless they tell you otherwise, you need to just assume it is counterclockwise. Now, counterclockwise is pretty standard in math. Think about the way we number the quadrants when graphing. Number them in a counterclockwise direction. So, unless they specifically say you're going a different direction, let's say clockwise, assume counterclockwise is the way we're going. The other thing you need to keep in mind is that there's an angle for that rotation. Or you're going to rotate at 20 degrees, 85 degrees. So there's a degree, and that angle can be found if you can look at your pre-image, identify some point, like I'm going to take Odie's nose right here, identify that point and come out to the center, and then find that same point in your image and come out to the center. And pretty much there's your angle. So that angle you found right there, that's the angle of the rotation. All right, grab your foldable and let's put some key information down. Pause the video and write this down. All right, if you've got that, let's talk through it. So when you do a rotation, do you change the size or shape of your picture? Not at all. So your pre-image is congruent to your image. One more time, guys, that is an isometry. And we just talked about that. You specify your rotation by the center, the angle or the degree measure, and the direction of your rotation. What is it going to be assumed to be? Counterclockwise. Keep that in mind. So how does it work? Well, we take our figure and we're turning it. Notice that as I turn it, there's only one point in this whole picture that's staying exactly where it was to start, and that is, yep, the center. This center point or pivot point, that's never going to change or move in a rotation. Everything else is going to move around it. And the thing that changes for our figure is not size or shape, but instead just the location, and I might add, I like to say the tilt of the image rotates. Some of you are going to have a really good eye and be able to picture exactly where these rotations go. For the rest of us, let's take a look for a pattern. Take a look here. We've got this triangle ABC, kind of like a flag coming out from the origin. And we're rotating it into the second quadrant. So there's been this rotation, a 90-degree rotation. And the rotations we're going to talk about are right angle rotations and centered at the origin. So we're looking for a pattern when that's the case. Take your A point and let's note those coordinates are 2, 4, and take a look at where it was mapped to. Where's A prime over here? A has been moved to -4, +2. Now there's definitely a pattern going on there. Let's do B and see if you can see that pattern. So B was at 3, 6, and in our rotation you take a look and find B prime over here located at -6, 3. Do you see what's happening? Check yourself with the C point. So C was at 6, 5, and we find its image after the rotation landing at -5, 6. So I hope you can see what's going on. We're doing something with these X's and Y's. A couple of things are happening. To me, it looks like the sign of our Y is changing, and it's also moving into the front spot. So 4 here was in the back as our Y coordinate, and then now we see it over here in the front, but it's become negative, so we've changed the sign of it. And that has moved the X onto the back. Did the same happen with B? Yeah, we'll take a look. 6 was the Y coordinate, and now it's sitting in the front as the X coordinate, and the sign's changed. And that 3's moved to the back as the Y coordinate. So that happens all along the way. So as a general rule, what we're going to do is we're going to negate the Y. We're going to negate the Y, and then we're going to switch their spots. Okay, as a mapping rule, it looks like this. X and Y turns into the negation of Y in the front, and X has moved to the back. Now let me show you how that worked with the second rotation. So let's take these points that are in the second quadrant and rotate them 90 degrees down into the third quadrant. Again, we look at that A prime that was in the second quadrant of negative 4, 2. And if we follow our rule, we should be able to get to A double prime. That happens because we've already rotated it once. This is the second rotation. So I'm going to take the 2, I'm going to move it to the front position and negate it as I do. So that's now a negative 2. And then I'm going to bring my negative 4 and just move it to the other spot. If you look here on the graph, you see that that's exactly where that point went. Okay, one more example with B, or B prime I should say. B prime was at negative 6, 3, right over here in quadrant 2, and it's rotated down into quadrant 3. Let's see if our rule applies here. So I'm going to take my y coordinate, I'm going to move it to the front, that negates it. I'm going to take my negative 6 and move it to the back position for B double prime. Same works for C prime. So I'm going to stop there, and I want you to try the next rotation. So your job is to take this third quadrant flag and rotate it over into the fourth quadrant, either by visualizing it or by doing our little mapping rule, and see if you understand this. Pause the video and you come back and check your work. All right, let's take a look at this. Here is the image after a rotation into the third quadrant. This has taken me from quadrant 3 into quadrant 4 with a 90-degree rotation. I hope you got that right. We're going to look at a couple of more examples here. So let's take this graph, and we're going to do a 90-degree rotation around the origin. Again, we're assuming that's counterclockwise, so that's going to take us from quadrant 4 right into quadrant 1 again. You might have seen this back on the notes. This is going to be a fancy schmancy R, and then a little 90 degrees to say the direction of the rotation. All right, if we start with point B, I'm going to list the coordinates of point B as it's sitting right now. So it looks like it's 4 units, and on our x it's negative 2. So it's a 4, negative 2. You know what? While we're here, let's just list them all. So let's take Z, and Z has a 0 coordinate with y is negative 3. And then R, I'm listing R here. It looks like it's 0 and negative 5 for y. Okay, so now my B prime, if I follow my rule, I'm going to move this y coordinate. I'm moving him to the front, but I'm also negating him. Now notice he's already negative, so what happens when I negate a negative? I make it a positive 2, and then my x value is just going to move to the back. So that's pretty much my rule. So B prime is going to be at 2, 4. So 2 over and 4 up. Right here is our B prime. And notice it is in quadrant 1. That's awesome. Okay, same applies for Z. We're going to take to Z prime. I'm going to take that y value, move it to the front and negate it, and move my x value to the back. So negating the negative 3 becomes a positive 3, and 0 goes to the back. Okay, so here's Z. Here's my rotation. It's going to take me right here. Notice the x is 3 and the y is 0. There's Z prime. One more for R. Same rule. Moving the y and negating it. It's going to make it a positive 5. Let me sneak my R prime in here. And moving that x to the front gives me the new coordinate 5, 0. So that's right here. And then I connect these guys up with the lines. And there's my rotated triangle. Okay, now in this example, we're kind of working backwards here. You get to identify the rule for this rotation. Take a look at what has happened. Basically, you want to see how many degrees it's rotated, and we'll just assume a counterclockwise rotation. And I think the sneakiest way to do this is to just draw your lines in. So you remember your center of rotation, that's the origin. Draw the line out to, say, point M, for example, and then draw the line to the image of point M. You are drawing the angle with this as the vertex. So here's the rotation if I'm going counterclockwise. Does not look like 180 to you? Sure does to me. Now notice something else. How many quadrants did point M pass through? It started here in quadrant 1, and it rotated through 1 quadrant, came through quadrant 2, and then it ended up down here in quadrant 3. So there's another way to take a look at it. Anyway, this rule for this rotation is it's a rotation, big fancy R. How many degrees? 180, and that's the way we write our rotation. Okay, Mrs. Pryor, that's all really good, but with 90 degrees, but how do you do these other rotations? Take a look at these examples. You're going to have to do different kinds of angle measures, but they are going to be sticking pretty much with quarter turns or right angle rotations. So you could learn a new rule. There definitely are rules, and you might come up with one. You might even be able to visualize this really easy, but if you need just one thing to learn, I would just stick with one 90-degree rotation, and then I would just break these down into other ones. For example, a 180-degree rotation, that's the same thing as just doing a rotation of 90 degrees and then taking those and do another rotation of 90 degrees. So just apply the rule twice. Let me show you what I mean with this example. So I want to go 180 degrees, so I'm going to go ahead and I'm going to say, well, let's rotate that 90 degrees. And then, after we've done that, then we'll rotate it one more 90-degree turn. That'll make a total 180. So let's do it. And if I apply my 90-degree rotation rule, I'm going to negate and move that y, and I'm going to just move the x. So what's that going to look like? My first rotation is going to move that 8 to the front, make it positive, and it's going to push the 14 to the back. That's the first 90-degree rotation. The second one is just to do it again. So this gets negated and moved to the front, and this one's going to be just moved to the back. All right, so 14's in the front, negated, and then 8's in the back. And this will be where my B prime is after two 90-degree rotations. So this is my final answer here. How's that? All right, well, think about a 270 now. A 270-degree rotation, how many 90 degrees is that? That's going to be three 90-degree rotations. So let's just take them all one at a time. So starting with E, we've got -5, -1. Let's apply the first rotation, negate the y and move it, and move the x. So the new first position is +1, and -5 has gone to the back. There's 1. Do it again. Negate that y, and move this guy to the front. What does that look like? So 5's negated, so -5 is negated. That's going to make it +5, and 1's moved to the back. Okay, there's the first one. Here's the second one. One more. Move that guy, negate him. That one comes to the back. So our final answer is going to be -1 and +5. There's your E prime. Oh, now here's an example. I wanted to throw this one in because this one is clockwise. So let's talk through that one. It's a 270-degree rotation clockwise. So let me come around 270 degrees. I'm just going to start here, and going clockwise, that's going to come around not a full turn, but 3/4 of a turn. We saw 270 was three 90-degree rotations. There's a 270 degrees clockwise rotation. Well, I'm just going to do this in a 90-degree piece, and the way I'm going to do it is I'm going to make it 90 degrees counterclockwise. So forget about clockwise. I've got a rule for counterclockwise, and I'm just going to do it the other direction. It's going to land me in the same place. Easy as that. So I'm going to take A, and I've got this at -19.3, and instead of doing a 270 clockwise, that is equal to a 90-degree counterclockwise, and that's what we have a rule for. So I just have to switch this around. So we're going to take that 3 and negate it, move it to the front, so it becomes a -3 in the front, and let this guy move to the back. So this is -19, and there's my answer. Your turn to try some.